Okay, today we're gonna be drawing the schematic for the kickstart of for the lowering of the cut-in speed of a windmill, wind generator, wind turbine, effectively from in the mid 20 kilometers per hour to down to about 13 kilometers per hour. Okay, as demonstrated on previous video. So I'm gonna draw the schematic so that anybody interested can see how I did that. And again, in a later video I'll be actually building this circuit again. I have mine built, but just so that you can see. Alright, so the main thing on this kickstart is getting a signal from the wind speed, determining when the breeze, in this case a light wind, is enough to give this a little push, kickstart I call it, and that's my own personal name, trademark for it, so that it can start turning in light wind. Alright, so the main component in here is a reed switch. It's in the anemometer right below the windmill. Okay, so I draw it like this, and this magnetic field turns it on. Okay, so this switch, one side is connected to ground, and the other side, which is actually the shield of the 3-wire cable I get coming from the generator, is this connection here. So I have 3 wires coming from the windmill, and the signal is coming on a ground, which is the negative, and the shield. So it's through the shield of the cable coming from the generator. Okay, so this is the anemometer. So every time anemometer turns, it turns the switch on by a magnet that's rotating. Okay, and so to this we have connected an LED, green LED in this case, could be any. And then we have a drop resistor, 1K, to limit the current, and this goes to plus battery on the system. Alright. Now this can stop anywhere and can stop right on the switch, so what do we need is one shot. I wrote this, it's going to be kind of in a way, but so we add a capacitor here, a 1 micro 16 volts, and then just going to draw a little longer line. I have a trim pot that adjusts the pulse or the charging, discharging of this capacitor, and that's 20K trim pot, so 1 micro. And then from here we go directly into a transistor, NPN transistor. And this usually goes to ground, but in this case, so this goes to plus. This goes to the next LED, and then we use the signal. So again, 1K, and this goes to ground. So this is actually the pulse that we get from this thing turning. Has somewhat adjustable pulse length or width. Okay, so then from here we have a diode, like signal diode 1 and 914 or similar. It's not critical. Could even be regular silicon diode, could be a germanium. In this case it's just a regular signal diode, so, which has a drop of about half a volt. Okay, so after this I have a capacitor. This one stores the pulse. This is 10 micro, 16 volts. Okay. And then we have so we have another trim filter. Sorry, trim pot to adjust the length of the pulse. And this is alpha 20K. And from here, then we have the output stage, which actually gives provides a pulse to the motor generator. In this case, so in this case, what I'm using is a motor from a treadmill, a permanent magnet. Permanent magnet motor that acts as a generator and you turn it, obviously. So you can provide juice to the motor, and it's going to start turning, and that's how this kickstart works, by sending pulses depending on the speed of the wind detected by this reed switch. You can look it up. Reed switch is magnetic. This magnet comes close, this closes. Okay. All right. So we drive Darlington set up here, transistor. Then this, by the way, is like 2N to the 904 or 2N2222. It's not critical, just a general purpose NPN transistor with a gain of up to 100 up to 100, and the series is the same transistor. And over here we're driving a power transistor, and again it's connected in Darlington configuration for increased gain. And this transistor is a BU4522 or equivalent, so it can handle about 10 amps of current, plenty of voltage, or similar. It doesn't have to be exactly. So this connection is green wire. So the ground connection on the system is black wire. That doesn't matter. In this case, I just have a 4-wire cable connected to this module that hooks up to my system. So that over here we have so this actually goes to the generator, motor generator. So directly. So motor generator, and then from here, of course, we have the rectifier diode, very important, and this goes to plus system, where there is solar generator and MPPT regulator for the solar. Okay, so this is the generator, PMG, permanent magnet motor generator. Okay, and from here I also have a LED indicator, so I can see the pulses and the voltage on. In this case, this one is a yellow. This one is green, and this one is green. Okay, this here goes directly to the battery plus 12 volts. Okay, this here transistor is on the heat sink. Okay, and again this is just 29. 3904. This is 680 ohm yellow LED. And that's about, wait, I skipped the resistor. I have a 3K9 resistor here. Sorry, that's over here. Okay, so this is basically to adjust the pulse duration, how much of a pulse goes to the generator, motor generator, to kickstart. So this is permanent magnet generator motor kick start. And that's to reduce and generator cut in from about 25 kilometers per hour to about 13 kilometers per hour, which is 3.6 meters per second, and 25 kilometers per hour to meters per second. It's about 6.9 meters per second. Okay, so in the next video, as I promised, we're gonna actually build this on a small prototype board. Okay, but it's going to be all ready to go. Okay, there you have it. Okay, and one more thing I didn't mark here. So this is the red connection. And as I said in my case, oops, sorry, this is the red battery, and this is, in this case, yellow. Wire. So 1, 2, 3, 4 wires to connect to the system. Okay. So I'm going to show you a block diagram of my system here. So motor generator, boost, actually that's 5 volts DC right now, boost, and the connection is actually right across the diode, and that's one of my discoveries, that I can do that. So this is the rectifier from the generator, and the boost goes right across, so that when this generates enough power for biases the diode, so it's the boost is bypassed. So this shows the solar coming in here, and this goes to the grid tie inverter, and I'll cover that also in next video, one of the next videos. The regulator MPPT charge controller for the batteries, and here's the kickstart. Okay, that we just visited. This here is optional switch that would have been working off of the kickstart circuit, a relay switch and a resistor, but actually I don't even have that, so that's not there. We'll cover this again later. This is just my other iterations of the circuit that didn't quite work that well. So that's what I drew here is what I have now. And again, in this iteration here, I had a op amp where I could set in cut-in and cut-out speed, just so that I can cut in the boost or cut out, but because of the way I figured to wire it, I don't have to do that. So here again, I'll show that here. So I have, but we'll cover that in the next video. Generator, okay, of course, rectifier, so that and this is like a 25 amp bridge rectifier, just one diode. So this is PMG, okay, and the PMG, by the way, is a 125 volts DC from a treadmill. Treadmill motor. Actually 3850 RPM. At 20 amps. So this serious motor, 3 horsepower. So the motor, the generator itself, has a potential of producing 2000 watts, but I'm not claiming that because of course that's dependent on the diameter of the propeller, the blades, the diameter of the rotor, and the design and everything else, speed and so on. All I'm stating here is that the motor is rated at 125 volts DC at 3850 RPM at 20 amps, and it's a 3 horsepower DC motor, permanent magnet DC motor. So anyway, so the kickstart, we'll just draw a box on here. Kickstart. And here we have a booster. So I simply have the booster, which is 5 volts DC power supply, going right across the bridge rectifier, and this then goes to plus system, where there is solar panels, and of course there's ground. to it. Also has ground plus battery connection, and it connects to generator. Okay, I'll cover that later. It's becomes a little messy here. Then there's a grid tie inverter, and that goes to 120 volts AC. So there's ground connection here, and then we also have the MPPT regulator for charging batteries. 12 volts DC batteries. Okay. So this is the solar, wind, grid tie, and battery. System. Okay. So this is the plus battery that's used over here, and it's used for kickstarting. Yeah. Okay. So anyway, that's it for now. I hope you enjoy this. Any comments you can put in below, and please like and subscribe if you like it, and share it. This is I've been working on this for a couple months, since March, when I started with my simple fan motor from a pickup truck, and then I switched over to build a real one. This is the first time I built a completely home built generator that's got some serious capability. Previously I've had solar panels and solar water heating panels and a wind generator 400 watts, but that was a purchased system, and that only charged battery banks. And then I had an inverter that had to be had separate circuits to drive, whereas this system has the grid tie inverter, so it's hooked up directly to 120 volts AC house power, and also has battery system. And I can get into more in that. That's distributed power, where I have one battery in a shed close to the solar panels, where the solar panels are, and the wind. But I also have two batteries in a house, and then I run that there's a couple batteries here in the house, so that I have 12 volts in the house, and I also have inverter 120 in a shed, and I'm backfeeding that's tied right into the household power. So batteries, they're just for storing extra energy and running small things off of it, and I can get into that as well. I'm slowly taking off things that like house phone, charging circuits, my cell phone charging and things like that onto from this system, 12 volts, and my wiring is through the existing phone wiring that's in the house, which I then use. I have a internet phone magic jack that is hooked up, so I only have a connection from the internet router to there, and then the phones and handsets are on Wi-Fi 2.4 gigahertz, I think. Anyway, so that's enough of that. We'll go into details later. Again, if you have comments, questions, put them below. If you like any of this information, which I think this is ingenious, this booster and kickstart, because otherwise I would have to have 6.9 meters per second or 25 kilometers an hour wind to start producing anything. Okay, so this way, because summer months, well, late spring right now, and it's summer, we usually have light wind speeds, which are from about 10 to 20 kilometers an hour. Before you just operated on moderate light wind, moderate wind is from about 21 to 30 kilometers per hour. And it worked fine on this before the circuit, but now I'm getting use of it when I have breeze, basically. Okay, all right, thank you for watching. Talk to you later. Bye.